Hi everyone, I'm Luke Herlihy, co-founder and the head of growth for Reveal. If you caught our founder and CEO, Sam Whiffen's presentation yesterday, you'll already be up to speed on what Reveal does. But to recap, Reveal builds field tool software and digital platforms to help the construction and infrastructure industries better understand and manage the risk involved with subsurface utilities. In this presentation, I'll demonstrate what that looks like in practice on a major civil infrastructure project taking place in New Zealand right now. This is a recorded demo, but the functionality I'll be showing here is live and in use by a major engineering alliance right now. We hope it shows the road to the future for a lot of engineers and project managers out there. As this audience will be aware, engineers and constructors are typically not experts in the subsurface. Subsurface risks are often pushed down to the workers in the field and to the contractors to deal with as they emerge. It's a reactive model which causes delay, unnecessary rework, and additional costs to the project funder. New Zealand, like many other developed countries, has a legacy of 150 years of subsurface infrastructure that has been thrown in the ground, poorly mapped and poorly documented. Information about subsurface utilities is held by the individual utility owners and operators, and there's no central management nor mechanisms for keeping the information up to date for users of the subsurface. Currently in New Zealand, when an engineer begins a new site project plan, their first step is to submit a request to a service called Before You Dig. They in turn relay the request for information to the various utility owners with known assets in the area. Not all utility owners are part of the Before You Dig service, so the engineer or project manager then needs to contact other known utility owners in the area directly to get plan information for their scope area. A process that can take days to weeks depending on the utility. The information the engineer receives back typically comes in the form of disparate, multi-page PDF documents, either historical plans which have been digitized or exports from the utility owner's GIS system. It's usually up to a junior engineer or draftsperson to painstakingly retrace all this utility information onto a master plan that can then be reconciled with the engineering plans. From there, the engineer or project manager in charge will sometimes commission invasive drilling or potholing to confirm the presence of utilities, or simply leave it up to the contractor to conduct the investigation. In this paradigm, utilities are a nuisance, an afterthought, and often both. At Reveal, we take a different approach. We've created a platform that puts information about the subsurface at the forefront of decision making. We want to allow asset owners, engineers and contractors to take the future-focused approach they are calling out for and think innovatively about the way they work with the underground. And it's our tools and workflows that allow them to do so. For our customers, a project often begins with existing utility plan information. The Reveal platform can ingest all the existing utility plan information into its single interface, either by geo-referencing plans or importing existing GIS sources of data. In our example project here, you can see all the different utilities color-coded. We've got water, electricity, gas, and communications plans from the various utility owners, all included here as separate layers that can be turned on, turned off, or filtered. For GIS sources, we can see any additional metadata provided by the utility owner. Useful to know when it comes to finding out more about an asset's type, material, or condition. Data ingestion into the Reveal platform follows the PAS 128 utility locating standard from the UK, which some of you will be familiar with. PAS 128 specifies the techniques that locators use to collect evidence of detection in the underground environment. Existing utility plans are one type of evidence we have to go on, but under PAS 128, they are assigned the lowest quality level grade, D. At Reveal, we typically refer to utility plans as QLD. I'll discuss the other quality levels shortly as we add more evidence of detections into our utility model. Even at this stage though, just having all the utility plans consolidated in a single place and on an intuitive map interface can yield insights for the concept design. Areas with a high concentration of utilities can be identified at a glance, and designs can be modified or timelines adjusted based on the information available. Under the PAS 128 standard, the next level of detection is called QLC, the reconciliation of above-ground features that can be inspected visually. Typically, QLC data points would include manhole covers, grates, and catchments that can be seen from the ground. If a person on the ground can walk a site with a 360-degree camera or a drone, you can gather lots of additional information which can be used to inform the unified utility model we're building up in the Reveal platform. Reveal's platform includes easy-to-use editing tools, so users can update the QLD information to reflect this visual evidence. For instance, in this area using aerial imagery, we can see a manhole cover here that isn't recorded on the underlying utility plan. Using our collection tools, we can draw a shape to indicate the location of this asset, tag it, and mark it on the map, so now it's part of the unified utility model. These markups can be performed by a customer or Reveal's data processing team of experienced geospatial engineers. One of the major advances in subsurface utility engineering over the past few years has been the introduction of rapid, mass data collection equipment like ultra-wideband radar. These units can be vehicle or even air-mounted, allowing much faster data collection in a road corridor. Detections from ground-penetrating radar are classified as quality level B and can provide a great low-fidelity indication of the presence or absence of underground utilities. To date, the output from the radar devices has been complex and messy and required a high degree of interpretation by trained specialists to make use of the information collected. Reveal has developed a suite of tools to automatically process and display radar data in a visualization that can be shown in our platform, alongside the other utility plan and marked up objects. If you're familiar with point clouds, you'll get the picture. In this area, you can see the radar signature responses have been color-coded, and we've retained the depth information, so you have a low fidelity but very fast and easy to understand method of understanding what you're looking at. This is where the real value of the Reveal platform comes to life. Through combining the different data sources together, like a mosaic, in a single interface. You can see the utility plans show there should be a large stormwater pipe going down this street. And sure enough, our point cloud data shows a large, solid object in about the same location, at a likely depth obtained from the radar detection. For our engineer customers, being able to see the correspondence between the theoretical plans and the survey evidence is fantastic. For projects with the limited investigations budget, you could mark this area as low risk, i.e., we're reasonably confident there's an object there and we know what it is. Further down the road, you can see radar has detected something, but there's no corresponding record on a utility plan in that area. We don't know or can't speculate as to what it might be, either an asset that hasn't been documented, or perhaps one that was decommissioned and removed from the plans, but not actually removed from the ground. This is high risk for contractors working in the area, and a priority target for invasive potholing or investigation to identify this asset and its owner. In this area, we can see the utility plans indicate there is an asset, but the radar hasn't found anything. This could be for many reasons. The asset might be too deep for radar to detect, or too small to return a reflection. Alternatively, the utility plans themselves could be wrong. We do see a signal running parallel here, which looks suspiciously like the thing we're looking for. With more investigation, a choice can be made to update the unified utility model to associate this line string with the detection, while retaining the original data in a layer providing traceability to the updated unified utility model. The gold standard for evidence of subsurface utilities is physically siting them before they are interred. Usually this occurs when the ground is exposed through excavation or when a new asset is being installed. Visual evidence of this type is termed QLA, with Reveal's platform also able to accommodate these data types. Here is an example of a photogram taken during an excavation period here in Wellington. The photogram has been georeferenced in place, and you can see the connection between the visual evidence and the utility plan data. In this case, the utility plans are almost spot on in their accuracy, although with the pipe here, you can see there's still a bit of discrepancy, which we can amend. The platform we've built at Reveal is not merely producing a snapshot in time to be referred to once and then archived. The data in the platform is designed to be editable and updatable through users interacting with the data via the viewer. As more evidence is obtained from subsurface detections, trial holes, or the eventual construction work, the unified utility model can be continually updated to reflect the best understanding of the subsurface environment, right up until construction is completed and the new physical and digital assets are handed over. The platform demonstrated today is continually evolving. We're working directly with our customers to find out how they want to view and use the solution, informing what we build next. As a cloud-based GIS platform and database, integrations with other GIS systems or design packages that can exchange GIS data are a priority for us. We're speaking with design engineers and CAD technicians, figuring out the best way for Reveal's platform to integrate with our customers' existing tools and workflows. As we ingest more and more data into the Reveal platform, we will build training data sets for machine learning and AI to further automate and straight-through process the data transformation and visualization that you see today. The digital platform and services we offer at Reveal are changing the way cities, asset owners, planners, designers, engineers, surveyors, and other actors involved in the world of the subsurface are thinking about utilities and their underground assets. It's an exciting journey and trajectory we're on as we drive a safer, more efficient and sustainable world as the go-to platform for insights on subsurface infrastructure, revealing the truth of the subsurface world. I'm Herlihy. Look after yourselves and continue to look deeper.